Okay, guys, lesson 3 of Unit 5. We're going to do some solving equations again today. Let's recap the types of factoring we have learned so far. Greatest common factor, GCF. We have learned difference of squares. That's like when you have a, say, x squared minus 25. And then trinomials, both the easy when a is an invisible 1 and hard trinomials when a is not equal to 1. When we get to example 2 on the next page, we're going to do a new way of factoring. It's factoring by grouping when you have a 4-term polynomial. But anyway, let's go back to example 1. We have equations here. We are going to find all the real or imaginary solutions. Remember that imaginary solutions have the letter I in them. And remember, always factor to start these off. So remember that in order to solve an equation by factoring, we must set it equal to 0. So a is set equal to 0. Then we always look for, do our GCF check. So do I have a GCF here? Yes, I do, for x. So then I divide everything by 4x to have 1x to the 4th. Minus 10x to the 2nd, plus 9. Okay, so after that, you look in the parentheses. It is a trinomial, what we have referred to before as trinomial to a higher degree. So bring down your GCF. That's very important. You're going to have two binomials here. Remember, when you have an x to the 4th, that gets divided by 2 to have x squared in both parentheses. My sign rules here are minus, minus. You should have them memorized by now. If you do not, you should pause this video, go into YouTube, and type in trinomial sign rules, or factoring trinomial sign rules. Two numbers that multiply to get 9 and add up to get 10 are 1 and 9. Can I factor further? Yes, I can. This guy is a difference of squares. This guy is a difference of squares. So we have a lot going on in this problem. So again, if you forget difference of squares, pause this video now, go to YouTube, type in difference of squares, catch up. So that should be x plus 1 and x plus 1. Sorry, I meant to say x plus 1, x minus 1. And the second one, x plus 3, x minus 3. At this point, you guys need to be perfect on GCF. You guys need to be perfect on easy trinomials. You guys need to be perfect on difference of squares. The only thing I don't, expect you to be perfect on is the hard trinomials. This other stuff's easy. So we had a lot of factoring here. We cannot break up anything further. So it's answer time. Since we have an equation, we are expected to get answers here. So remember, the rule is we set each of the factors equal to 0. I'm just using commas to separate. So this first one would be 0, x equals 0. The second one would be negative 1, 1, negative 3, and 3. You actually get 5 answers here. And notice something. Look back at the original problem. Notice the highest exponent is 5. That means we can get up to 5 answers. It doesn't necessarily mean the highest exponent will be the exact number of answers on every problem. It just means it could be up to 5 answers. Okay, let's try letter B. Okay, I have a I'm going to check my GCF. Yep, 2x, and then divide by 2x, 1x to the 4th, minus 37x squared, plus 36. I have a parentheses. I have another easy trinomial to a higher degree. So I'm going to go 2 binomials. Make sure to bring down your 2x. X to the fourth gets split up into x squared. Your sign rules here are minus, minus. Two numbers that multiply to get 36, add up to 37. They would be 1 and 36. All right, so I'm looking to see if I can factor more. Yes, I can. Bring this down. X squared minus 1 is a difference of squares, so that'll be x plus 1, x minus 1. X squared minus 36, also difference of squares. X plus 6, almost forgot the x minus 6. Okay, now we're ready to answer. I'm going to give you guys a little bit of shortcut. You don't need to write for me the equations, 5 different equations. These are so easy. You can go right to the 5 answers. So, like the first one here, when it's 2x equals 0. Anytime you have a GCF with an x, it's just a 0 coming out of it. This guy would be -1. This guy would be 1. This guy would be -6. And this guy would be 6. So with the solving equations at the end, you can take some shortcuts there. So we had 5 answers. What does that mean, by the way? That means if we were to graph this thing, if you go into this, it's a website called Desmos, and you type in the original problem, it will graph it for you. It'll show you what the graph looks like, and you will notice that the graph will cross the x-axis at those 5 numbers 5 times. All right, letter C. We need it set equal to 0. So we need to subtract 18x to the third from both sides. Notice my placement of it. It has to be in standard form, highest exponent down to the lowest. Now I'm doing my GCF check. Yep. 3 and x. Divide by 3x to have 1x to the fourth. Divide minus 6x squared and divide plus 5. Okay, I have another, it's very similar to the ones I just did. I have another easy trinomial to a higher degree, so 2 binomials. X squared, x to the fourth breaks up into x squared in both. Sign rules here, minus, minus. 2 numbers that multiply get 5. And add up to 6. Obviously, your only choices are 5 and 1. Okay, can I factor further? 3x, just bring it down. X squared minus 5 is not a difference of squares, so you cannot factor this any further. This one here, though, is a difference of squares. X plus 1, x minus 1. Okay, now that everything's factored, it's answer time. And this one's going to get a little more difficult with this guy here. I'll save that for last. So your first one, x equals 0, very easy. This one, -1. This one, 1. Now let me go back to this guy. It's a little more challenging, because you can't just say it's 5. It wouldn't make sense. There's no way it can be 5 because that's an x squared. And if you plugged 5 in here, that would be 5 squared is 25 minus the 5 is 20. You need the number to make it 0. Remember that. So you should set up an equation on the side, set it equal to 0, and then solve that guy. We're going to solve it by square roots. So we get x squared by itself. We're going to add 5. Then we're going to take the square root of both sides to have x equals. Don't forget your plus minus. And then square root of 5, can you simplify it? Absolutely not. It's a prime number. It would only be 1 and 5. So therefore, you have 2 more answers, the square root of 5 and negative square root of 5. Letter D. We need to set it equal to 0 before we factor. All right, this guy is actually a difference of squares. binomial with a minus sign and square rootable numbers. So go to your two binomials. I hope you guys are pausing and writing down the notes as you go through this. 81x to the fourth is, remember, we're square rooting the number but dividing the exponent. So 9x to the second, plus minus for difference of squares, and the square root of 16 gets 4s. Okay, can I factor further? The second one is actually difference of squares again. That would be 9x squared, square rooted is 3x. We got our plus minus, square root of 4 is 2s. However, the first one is not a difference of squares because it doesn't have a minus sign. We call it difference of squares because the word difference means a minus sign. So this is completely factored, so it's answer time. So these definitely don't take shortcuts here on these problems. They're not incredibly easy, so write them out. So set this equal to 0. We're going to solve this for by square root method. So we're going to subtract 4. We're getting x squared by itself. Divide by 9. You do not want a decimal here. Keep it 4/9. There's a reason. And it is because when you square root both sides to get rid of the exponent, we're going to have a plus minus and an I, and then the square root of 4 and 9 can be square rooted. Square root of 4 is 2, square root of 9 is 3. We're going to rearrange that though. We're not going to make it I 2/3. It would technically be 2/3 I. The 2/3 is a coefficient. All right, so there's two answers, 2/3 I and negative 2/3 I. All right, now the other one, or the other two, set them equal to 0 and solve them. Subtract 2 and divide by 3, and we would get negative 2/3. Next, add 2, divide by 3, and 2/3. So we have 4 answers here. We got 2 here, and 3, 4. And guys, please circle your answers in your homework for me. Help me out a little bit. Sometimes you guys don't, like, notice when I show my work, I go down. Some of you guys are like going down, over, up, you know, all over the place, and I don't understand what some of that stuff is. So please circle your answers for me. All right, so let's set this equal to 0 before we factor. We are going to subtract 48. Do I have a GCF here? Yes, I do. It is just 2. No x with it because the 48 doesn't have an x. Divide everything by 2. Now, the 2 out in front doesn't have an x, so we don't need that anymore. If it has an x, if a GCF has an x with it, we'll get an answer of 0 from it. If it doesn't have an x, it does not help us get an answer. All right, so what's left? We got an easy-looking trinomial, just to a higher degree. So let's go to binomials. X to the fourth is x squared in both. Your sign rules, the c is a minus, so that's plus minus. I need two numbers that multiply to get 24 and subtract to get 10. That would be 12 and 2. And remember the phrase that I use, the sign of b goes to the bigger number when they're different signs. So therefore the minus goes with the 2. Can I factor any further? The first one has a plus, so no, it's not difference of squares. The second one looks like a difference of squares, but you can't square root of 2. So these are done being factored. It's answer time. So I'm going to set them equal to 0. And I'm going to solve by square roots. The first one, subtract 12. Square root to get rid of the exponent. Don't forget your plus minus. There is going to be an I that comes out. And then we want to simplify the 12. So remember, we think of a perfect square that multiplies into 12. The highest perfect square that multiplies into 12. That would be 4, such as square root of 4 times the square root of 3. The square root of 4 will become 2. So it'll be plus minus 2i root 3. The square root of 4 is 2. It should not have a radical anymore. Alright, so there's two answers. They are actually imaginary solutions because they have an I in them. Solve the second one by square roots. We're going to add 2. Square root, get rid of the exponent. Remember to plus minus. And square root of 2 definitely cannot be simplified, so we have 2 additional real solutions. So this problem we had 2 real and 2 imaginary. The imaginary solutions would be like if you have curvature on a graph, but it doesn't touch the x-axis. Okay, letter F is set equal to 0. Do I have a GCF? Yes. What is it? Nope, not 15. It is 5. 15 doesn't go into 65, so it's just a 5 here. It's actually 5x. All of them have x. You go with the smallest one. So I divide by 5x to have 3x to the second plus 13x plus 4. Okay. Now, here's the deal. This leftover is a hard trinomial. In these problems, when you're solving, some hard trinomials cannot be factored. Therefore, I'm not even going to try to factor them. When you get to this point where we're at, in this form ax squared plus bx plus c, when those exponents in order are exact, the way I would encourage you to solve this is by using the Pythagorean Theorem, which I did tell you guys to memorize at one point. Now, before I go into the Pythagorean Theorem, I'm not going to forget about this guy. Remember, I do get an answer out of him. The GCF has an x, so that's 0. 5x equals 0. So now I'm going to go to my Pythagorean Theorem. If you guys are shaky on the Pythagorean Theorem, please remember, pause this, go look it up. You guys took a test on it, so you need to be good on it. So x equals negative b plus minus the square root of b squared minus 4 times a times c divided by 2 times a. Don't have a lot of room here. Remember, you are going to multiply your 3 times the start. 1, 2, 3. $13 squared. And then minus 4, 3, 12, 48. On the bottom, 2 times 3, 6. Then we're going to subtract to get the square root of 121. Then we simplify the radical. Square root of 121 is 11. Now, when there's no more radical, remember you are supposed to split it up and get your 2 answers. Just a little bit of arithmetic. A lot of you guys forgot to do this on the test. Splitting up. When there's no more radical, you got to split up and get 2 distinct answers. So add, divide, subtract, and divide. So there are your three answers. In the top left of the screen, you got 0, you got -1/3, and you got -4. Okay, guys, I'm going to pause this video, factor by grouping. I'm going to have a part 2 for today, so be on the lookouts for that also. So hang tight.